Good afternoon. Please, everybody, take your seats for this afternoon's ArcFlash University webcast, Safe Use of Electrical Testing Devices. I'm your moderator, Bob Vavra, Content Manager for Plant Engineering. Happy to join you this afternoon. I'm really pleased to welcome Bob Lamastro to today's ArcFlash University. Bob's a former combat engineer, Green Beret, Navy Hospital Corpsman, and supervisor of the National Safety Council Safety Training Institute. So Bob and I are part of the same alumni association with the National Safety Council. Bob holds a master's degree in safety management and engineering with bachelor's degrees in business management, construction engineering, and nursing. As president of Lamastro & Associates, Bob draws upon a career of more than 30 years teaching safety and health-related topics for government, general industry, and construction companies. He teaches a wide range of safety and health topics and has developed an awareness of exceptional skills and best practices in electrical safety demonstrations for OSHA and NFPA 70E compliance and awareness. We're really pleased to have Bob Lamastro speaking to you today on behalf of ArcFlash Safety in the U.S. and all over the world. Bob, good afternoon.
Hi, Bob. Thanks for inviting me, and thanks for those of you who have attended. Today I'm going to be using an e-learning module that was developed for us by Wes Van Huss, my training manager. A common cause of arc flash and arc blast is the misuse and the use of a damaged testing device. The Bureau of Labor and Statistics has reported that over 1,000 workers were electrically burned in a single year. Half of them as a result of arc flash or arc blast. Electrical industry experts estimate that an average of 5 to 10 arc flash incidents occur every day in the U.S. Our course objectives today start off with the determination of the hazards that are associated with electrical testing. We also want to cover the selection of the correct type of electrical tester, and that's going to be dependent on the task that you're assigned. We want to properly inspect our meters prior to use to make sure that they're not damaged. We want to verify that our meter is working properly both before and after our test. We want to know where to go to determine the correct PPE for the task. And we're going to be using the NFPA 2012 edition as our guide for this information. I want to make a point that every meter is different. And so during this webcast, we're going to be doing an overview of electrical testing equipment. But for specific information, always refer to the owner's manual for the use, the limits, and the controls of the type of meter you have. Let's watch this video and see how this can go wrong quickly.
I noticed when I plugged the thing into that, it was... Oh, wait. Hold on. Don't do it. Wait.
It melted your piece right there. I see that. Look, come here. Come here, Nathan.
Yeah, I see it.
Oh, you see it?
I already saw it, yeah.
All right.
Hold on.
Yeah. You get the...
Don't touch it yet. Don't do it. I think you tripped the breaker again.
Oh my god.
Oh my god, dude.
No.
You alright?
Okay.
Let's do it again. You alright, man?
Oh man, I'm good. I can't feel my arm.
Yeah, it melted it the second time too.
Leave it down. Oh my god.
Oh my god.
Shit. Okay, I'm gonna try to get up.
Yeah, you tripped the breaker. Unplugged? Oh, yeah, it's unplugged. Alright, breaker's back up.
Okay, there's a lot of things we can talk about with this video. But the first thing I want to point out is this guy is ignoring all of the warnings of the people he's working with. They're telling him to wait, to stop, and he just proceeds right ahead. Now, first off, I want to mention this concept of confidence and bravado. They do not substitute for the knowledge, the training, and the proper use of equipment. When I hear people say things like, don't worry, it's only 120, or occasionally I've heard somebody say, don't worry, he's grounded, it just makes me cringe. So I want to ask all of you a question. How many of you would have called 911 immediately? I know if we ask the victim, he's going to say, no, I'm okay. But think about it. Now, first off, it knocked this guy to the ground. You need to make the call. And if your victim is moaning in pain, I mean, he's not just responding to a tingle, you need to make the call. And then when somebody says something like, I'm okay, but I can't feel my arm, you need to be dialing the phone. I mean, let's face it, guys are going to say they're okay no matter how bad the damage is. And electrical injuries, they burn from the outside in and the inside out. There can be a tremendous amount of damage underneath the skin that he cannot see or feel. Talk a little bit about the medical care provided. You know, the standards require that our qualified workers, and we're going to discuss that here in a minute, be trained in the hazards associated with electrical work, the proper use of PPE, the proper use of their tools, but they also have to be trained in first aid, CPR, and the use of automatic external defibrillators. Rubbing that guy's arm was not the appropriate treatment. So let's talk about qualified workers. First of all, let's break this down. You are either qualified or you're not. And qualified means trained on the specifics of the equipment that you're going to be working on. And you have to be authorized by your employer to do that particular task. Finally, you have to have the proper equipment for the task you've been assigned. If you don't have all three of those, you're an unqualified worker. Here's another video clip I want you to see.
Since it was so hot and nobody was around to see, I decided not to wear the hood. I had all the standard excuses. It was hot and uncomfortable, but I think the real reason was my attitude. It was a fairly new procedure, and I just didn't understand why I had to wear it, and I resented being made to.
We have a worker who's been properly trained, the equipment is available, but he made this decision not to wear the right equipment. And I think a lot of this can be overcome if we make the workers understand why we're making these changes in the workplace. It's not enough to write a memo. They need to understand the purpose of these changes. So ultimately what we want to do is we want to keep our workers safe. I apologize for the glitch here on the slide, but let's use the word safe as an acronym. The S, in this case, stands for electric shock. And anytime the worker is exposed to the potential of live electrical parts, the risk of shock exists. Our next hazard is the risk of arc flash or arc blast. Now, an arc flash doesn't last very long, about a second. But in that second, temperatures can reach anywhere from 10,000 to 35,000 degrees Fahrenheit. And pressure waves can be delivered anywhere between 100 and 200 pounds per square foot. You know, in one of my past lives, I was a demolitions expert for Special Forces. I was curious about these numbers. I went back, I looked at some of my old demolition logs, and realized that we're talking about between 2 and 10 sticks of dynamite. Next, we deal with what's known as the falls, the fires, and the foul-ups. These are the other things that are going on while we're doing the electrical work. Are we working up on ladders? Are we in the bowels of the building? Is there mechanized vehicles in the area around us? And then lastly, the risk of electrocution. And this means death. You know, I had a guy come to me after a class one day, and he said, you know, Bob, I've been electrocuted like 4 times. And normally I'd respond by saying, no, you mean shocked. The more this guy talked, the more I realized he might be telling the truth. I got another video clip for you here. Okay. Well, one of the problems we have in the field of safety is we tend to break everything down into little mini topics. But when it all comes together in the workplace, we have to evaluate all of the risks of confined space, the risk of elevated work, and all of the other things that could be going on while we do the electrical work. So we're here today to talk about electrical test meters, and they're used for a wide variety of tests. And most commonly we see people using multimeters, which can be used to test the voltage, the current, resistance, temperature, frequencies, checking diodes. A multitude of tests can be done. In addition to our multimeters, we have solenoid testers, we have clamp-on meters, and finally we have the voltage detectors. Now I hear a lot of people talk about these voltage detectors, in a bad way. They have their purpose, but we have to understand the limits of a voltage detector. It's used to determine that power is on. It cannot be used to determine that the power is off. Most voltage detectors have a range of 50 to 100 volt detection. Well, they go as high as 600, but they don't sense a voltage until 50 volts. When we do lockout tagout, we're looking for 0. The other problem with voltage detectors is they can't measure through insulated cable, and they can be canceled out if they're between 2 fields. So they're not used in lockout tagout. And remember, always refer to your owner's manual for the specific use limits and the controls of your meter. So again, we have multimeters, and they come in a variety of shapes and sizes and different qualities. I guess this is a good place to point out you get what you pay for. Now, this $3.99 meter may be fine for working on your lawnmower, and you might feel comfortable using it on your car, but I don't think you should bring it to work. We have here we have solenoid meters, or what some people call wiggies, and these are used for both voltage testing and continuity testing. I want to point out that this image we have in the front is an ideal solenoid tester, and it was the subject of a Consumer Product Safety Commission recall. So if you have this type of meter, or any type of meter, be sure to check periodically to make sure there's no recall. Next, we have our clamp-on amp meters. And today we have a wide variety of tests that we can do with these. There's a lot of bells and whistles and additional features that you can get to use with it. Now, once we've determined what type of meter we've got, we need to make sure that our meter is in the right rating for how we're going to use it. Meter ratings come as category 1, 2, 3, and 4. A little graphic designed to show you how these are broken down. I'll hold on a second here. First off, I want to say category 1 meters are only used for electronics. So here's our graph. You can see Cat 1 meters used for electronics. Our Cat 2 meters are used for branch circuits, long branch circuits, and low incident energy exposures. Cat 3 is for service entrance, distribution panels, or high incident energy. And lastly, Cat 4 is for distribution, outdoor wiring, underground. If you want more detail on this, you can always look up the IEC or the Underwriters Laboratory standards for it, 61010. Now, as we can see on our meter here, It's rated for Cat 4 up to 600 volts and Cat 3 for 1,000 volts. So it has dual ratings. Your equipment has to be listed or labeled by an approved testing lab. In the U.S., that means Underwriters Laboratory, Factory Mutual, ETL, or the Canadian Standards Association. The European is TUV. And in addition to this label or listing, it's nice to see double insulated on the back of our tools as well. We have another video showing a destructive level test that's performed to make sure that the meter meets those standards. The purpose of taking these meters through a destructive level test is to see how it's going to react under a load. You know, we want to know, is this fuse quality enough to prevent it from becoming a bomb? Will it just blow a fuse? Will it start to arc and spark and burn up in your hand? Or will this thing blow up into fragments? Now that we've talked about having the proper quality of meter, in other words, a Cat 2, Cat 3, or Cat 4, we need to start doing our hazard assessment. Is there a risk of shock or arc flash? Now, the best resource for this is going to be NFPA 70E, and we like to use the latest edition. If your workplace has already had the hazard assessment, then we should be posting that information on the equipment. You can see on this label here, it indicates our flash protection boundary, in this case 89 inches, the flash incident energy, which is posted here as 16.4 calories, which puts us into Class 3 clothing. Now, I want to point out that the difference between the hazard category for the meters, it's different than the hazard category for clothing. Also on this label, we see the voltage and the proper gloves to wear. 00 gloves are good up to 500 volts. And we have our shock protection boundaries. A limited approach boundary of 42 inches, a restricted approach boundary for non-contact type work at 12 inches, and the prohibitive zone is 1 inch. Now, no matter what category of hazard we're working in, we're going to have to wear the proper clothing. Clothing boundaries are rated Category 0, 1, 2, 3, and 4. And Category 0 is the only level that doesn't require ARC-rated clothing. You still have to wear long-sleeve shirts, long pants, and hearing protection. You have to select the proper gloves. Again, I want to point out that glove categories are not the same as our hazard categories. Our gloves come in 6 different levels. 00, which is good to 500 volts, and are proof tested at 2,500 volts. And then we have categories 0, 1, 2, 3, and 4. Our gloves need to be tested every day we use them, and back to a destructive level test at a lab at least every 6 months. In addition to the clothing and the glove requirements, we must use dielectrically rated tools inside the limited approach boundary. And when we say insulated or protective tools, we don't mean wrapping Super 33 tape around the handles. These tools have to be tested and approved by a lab. Now we're ready to inspect our meter. When you inspect your meter, the first thing you want to check is to make sure that there's no damage to your leads, that the ports are in good shape, your indicator window and fusing is all in good working condition. Never use a damaged tool. And don't replace quality leads with cheap stuff you buy off the shelf. If your meter passes inspection, you got to verify that your meter is functioning properly. We do this, we call this a live, dead live process. In other words, we're going to go to a known source and test our meter if we're testing voltage in the same range of voltage that we want to perform on our equipment. If the meter works properly, then we can go out and do our tests. When we're finished with that testing, we go back to our known source to assure that the meter is still working properly, because you could have damaged that meter in the previous testing. Again, that's called live, dead, live testing. Another common mistake I want to point out here is many meters have what's known as a hold button. You want to make sure that's not locked in, because if it is, you'll be getting invalid results from your test. Hopefully we all agree that the days of checking for voltage with wet fingers is behind us. We're going to use a quality meter. Here we see a picture of an individual who's properly equipped and prepared to go in and do our voltage testing. So let's do a couple of quiz questions. Which meter offers us the widest variety of testing options? Yes, that would be our multimeter. What category of meter do we use for distribution systems? Category 4. Which agency provides listing or approval for electrical equipment? And remember that every piece of equipment must be listed or approved. And in the U.S., that would be Underwriters Laboratory or the Canadian Standards Association. So now that we've done all our pre-work, we're ready to perform our tests with our multimeters. For voltage testing, it's important that before we go in, we want to make sure that our meter is set to the correct meter setting. We want to make sure that our probes are in the proper jacks and that you have all the right equipment for the live work. In this video, we'll see voltage testing done in a panel board.
Note that in the video, the electrician makes contact with the grounded conductor, or otherwise known as the neutral, first, then makes contact with the ungrounded conductor, otherwise known as the hot, last. This is done because if the ungrounded conductor is made contact with first, then the other probe is energized and electricity is looking to complete a circuit home. He breaks contact with the ungrounded first and the grounded last for the same reason.
All right, again, I want to point out that it's important when we're doing this type of test that we always make contact with the grounded conductor or the neutral first, and then we make our contacts with the various ungrounded conductors. This is because the equipment would be fully energized once we make that contact. If we're going to do current tests, we want to make sure that we recognize that this is extremely dangerous because we're doing this under a system under load. The biggest risk you're going to find is when you move the wiring around so that you can get your clamp around that wire and that the wire can come loose. This can cause a phase-to-phase or a phase-to-ground. We want to make sure, again, that our meter is in the correct meter settings, that our probes are in the proper jacks. Again, we have the right equipment for this type of test. Here we'll watch an inline current test performed. Now, before this is set up, we lock the equipment out, make sure that we do a test to make sure that it's been de-energized, then we put our inline leads in place.
In this video, we're performing an inline current test. We have de-energized the system and placed the meter in line with the circuit. When the circuit is energized, the full load current on that circuit is flowing through the meter. This is done on systems that have a low current draw.
Okay. Our next video is going to show the same type of testing, but this time done as a clamp-on, not an inline.
In this video, we are performing a clamp-style current test on a single-phase panel. We will be testing the hot conductors to measure the imbalance between them. Notice that one leg is substantially higher than the other.
Our final series of tests are going to be continuity testing or resistance testing. Now, in order to do this safely, we have to have locked, tested, or locked, tagged, and tested the equipment first. We again call this live, dead live testing. We want to make sure that our meter is on the correct settings, again, that our probes are properly placed, and that we have verified with a contact test that the system is electrically safe. Our first test is for motor resistance testing.
Remember, continuity testing should be done with the system de-energized, locked and tagged out, and proven that it's de-energized with a voltage test.
This is also known as a live, dead, live test. In this video, we're doing a resistance test on the windings of a three-phase motor. This can be done to diagnose any problems we might be experiencing with the motor.
In this test, we're going to be testing the same motor, but we'll be testing at the variable frequency drive.
This resistance test is also being done to diagnose the windings of a motor. However, this test is being performed from the VFT that feeds the motor. This is useful when we don't have access to the motor itself.
And our final resistance test will be done on a cord and plug piece of equipment.
This test is being performed to check the windings on a single-phase motor. However, this motor is part of a cord and plug tool, so we will be performing the test through the cord.
Okay, we've briefly covered the proper process to go through these tests. We've done voltage testing, we've done current testing, and we've done our resistance testing. Let's do a little quiz. What resource provides the guidance on proper clothing and clearance distances to perform safe electrical work? The answer is NFPA 70E. OSHA tells us what we have to provide in the way of protection, but not how to provide that protection. When must a meter be verified to assure that it's functioning properly? And that's before and after every test, what we call the live, dead live testing. Information on hazard assessment for each piece of equipment can be found in NFPA 70E or on a detailed label found on the equipment. Now, NFPA 70E says that we have to review those assessments at least every 5 years unless there's been changes in the equipment or the process, which would mean we do it more often. When are dielectric gloves required? Anytime there's a task where the risk of shock exists. Ultimately, what determines whether or not a person is qualified to perform electrical testing? And that's the employer's responsibility. Has this worker been trained on that equipment? Are they authorized to perform these tasks? And have we provided them? And are they wearing proper equipment? Proper PPE must be worn during the lockout verification process. It's true. You don't know if that equipment is shut off just because you've thrown the handle. All you know for sure is that the handle moved. Got to test it out. So a circuit is considered energized until you've proven it's de-energized by a contact test. You cannot use a voltage indicator for this. It will not guarantee zero voltage. Employee training should be an ongoing process. The NFPA requires that we do training if the annual inspection identifies there's some issues of noncompliance. Anytime new equipment, technology, or procedures are brought into the workplace. If we're doing any unusual work practices, and it states very clearly in the standard that any job you haven't done within the last 12 months needs to be considered new work. And we need to review their training at least every 3 years. So, congratulations, Bob. Apparently you got 100% on the quiz.
No, I only got 80%, but...
Oh, no, you got 80 points. That's all I'm going to give you today.
Oh, that's fair enough.
Let me summarize very quickly. Only qualified workers, workers who have been approved by their employer, can perform any type of electrical testing. Before any testing is done, a complete hazard analysis needs to be performed. We're looking for shock hazards, arc hazards, or any other hazards that may be present in the workplace. We can only use the correct type or rating of electrical tester for the task assigned. And again, I want to make sure we understand that the rating on our meters is not the same as the category rating for clothing. Inspect your meter prior to every use for damage. Verify that it's working properly before and after your test by doing the dead live testing. And always wear the correct PPE. I understand many times it seems inconvenient, but the potential hazard is life or death. And remember, it's always considered live until you can prove otherwise with a contact test. Thanks. I appreciate your time. Bob, I'm going to turn it over to you at this point for the questions.
Thanks, Bob. Tremendous presentation, one of the best we've ever had here at Arc Flash University, and really enjoyed the presentation, the videos, all aspects of it, and we'll get to as many questions as we can. If you've got a question for Bob, type that question into the Ask a Question box on the console. We'll get to as many of those, as I said, as we can. We also would ask you to take a moment to fill out our exit survey, answer a few questions about today's presentation. We use those answers to help make improvements to our Arc Flash University series and other plant engineering webcasts. Also, an archive version of this, as we mentioned at the outset, within 7 days, the archive with the Q&A will be posted to plantengineering.com. We'll send an email to all of our registered attendees, and you can also access this by going to the plantengineering.com homepage and under our webcast tab, and you'll be able to see some information there as well. We're joined also on this question and answer part of the webcast by Wes Van Huss, who's the Director of Safety Training for Lemastro and Associates. And Wes, good afternoon. Welcome to the webcast. We've got a number of questions, as you can imagine, from our audience, and we'll get to as many as we have time for in the next 15 minutes or so. First questions come in. When operating a power circuit breaker installed in a metal cabinet, if the breaker is behind a steel door and the controls or pilot switches installed in the front panel of the enclosure so the breaker can be operated with the doors closed, is it safe to open and close the breaker under load?
Wes, do you want to go ahead and handle that one?
Sure. Well, anytime you're opening or closing a breaker under load, there's the risk of arc flash. So if we can de-energize the system we want to, or shut down as many things that could be drawing current prior to throwing the breaker, it can be done. It actually happens quite frequently. Just always be prepared that it could go wrong. So we're going to follow what we call the left-hand rule. We're going to use our non-dominant hand to throw the breaker or overcurrent device. And we're going to turn our head away from prior to and take a breath before operating the handle. That way, if something does go wrong, at least we won't be right in front of it.
Well, and I'd like to emphasize, Wes said, turn your head. Remember, this is an arc. And just like if you were watching somebody arc welding, there's potential for serious damage to the eyes. He said, take a breath before you throw the handle. If the temperature is somewhere between 10,000 and 35,000 degrees, you don't want to inhale that. Hopefully that covered the question for you.
Oh, sorry, hang on. I got one more. I'd like to add one more thing. There is also a description of this under 70E. It will say if you are performing the operation of a circuit breaker with covers on, it will tell you, depending on the voltage and the type of equipment that you're working with, it will tell you what category and what PPE you need to be wearing during this process.
Yeah, and if I recall correctly, in 240 volts and below, that's rated as a hazard category 0. And I want to make sure our listeners don't get don't misunderstand. It's rated as a category 0. That doesn't mean 0 hazard. It's just the lowest hazard rating. Mm-hmm. Go ahead, Bob.
Yeah, I was going to say, we always begin this process by saying, if you can de-energize the equipment, that is always the safest way to go in and deal with that. We understand that's not always possible, but the first default place to go is de-energize, and then everything else in 70E goes from there.
And I'd like to add a point to that. You know, a lot of times people do this because they're feeling the pressure of production. And my answer to that is you can never do a job any faster than it takes to do it safely.
Yeah, I think that's an excellent point. That kind of segues nicely into this question from one of our attendees. What are some of the best practices you've encountered that minimizes exposure to live electrical during testing and troubleshooting activities? Equipment design, portable guarding, covers, etc. What are some of the best practices out there that you both have seen and experienced?
Wes, go ahead.
Okay. Well, some of the things I've seen, some of the new meters actually have removable displays. So let's say if you need to get a current reading, you can, on a system that's rated dangerous, that's above 40 calories, where we can't feasibly perform energized work on it because if there is an arc blast, we more than likely will not survive. But having a removable display allows you to de-energize the system. Go ahead and check and verify that it's off. You can place your current clamps or whatever your type of test you're trying to do on the equipment. Now you can take your removable display and go up to 30 feet away with it, re-energize the system, and so you're not exposed to the hazards involved. Some other things that can be done, you can actually place, I don't know the technical name for them, but they make little devices that go into the panel covers where you can verify if something is de-energized right from the panel cover without actually having to open up the equipment and go in. You can do your testing right from the cover.
Yeah, another great improvement in today's technology is the use of infrared cameras and installing the infrared windows on the cover so that we don't have to open the cover to get a good infrared shot. And that can anticipate a lot of the things that might result in an arc flash.
Yeah, I think there's never a completely foolproof, but the more that you get at the understanding what state your equipment is in at any given point through testing, through IR, whatever you can do, is a real advantage. Another question in from our readers, are meters and instrumentation permanently installed in power distribution equipment acceptable for verifying power has been disconnected, or does an electrician in PPE still have to open the covers and take manual voltage readings?
Well, the thing we have to accept is that because that meter is showing 0 doesn't mean that the meter isn't damaged. It's a great feature so that we don't have to regularly go in and test. And if you go and see that the voltmeter is showing voltage, you can go ahead and accept it. But you can't accept it as a 0 because, once again, if that meter is broken and showing 0, you're going to anticipate no voltage when you go in, and that's dangerous. Wes, did you have anything to add to that?
No, that was well said.
Okay. Will a comprehensive maintenance plan for my electrical equipment reduce the potential for arc flash?
Significantly. Housekeeping is a huge issue. In this comprehensive maintenance plan, are we exercising our breakers? You know, most manufacturers recommend that circuit breakers and disconnects be manually turned on and off at least annually to make sure that contacts aren't melting or anything of that nature. Wes, did you have anything?
Yeah, any equipment that sits over a period of time and it doesn't go through any kind of maintenance, the risk of having a problem, the risk of an arc flash is greatly increased. You're going to get buildup of dust, you'll get corrosion, any kind of corruption, and sometimes contacts can fuse or weld together. So even if you flip the handle of the breaker or of the disconnect and you think it's off, it's welded in the closed position. It's on. And
after an arc flash incident is the wrong. I'm sorry. After an arc flash incident is the wrong time to be doing maintenance. Yeah. You know, one of the things we talk about in terms of maintenance is being really proactive about it. And I've heard of instances where spider webs inside the breakers have been known to cause arc flash.
Bob, I've had people send me pictures where the panels, because of an unused opening, had allowed rattlesnakes to fill. And they show me pictures that there's not a cubic inch of space that isn't filled with rattlesnakes. That'll bring up the pucker factor.
Yeah, I'm not sure shocking rattlesnakes is a bad idea, but certainly not in your electrical equipment. So, another question: are sub-panels likely to have an arc flash event as compared to a primary panel or a switch?
They can have arc flash events. The sub-panels have lower incident energy generally. But that doesn't mean that anytime we're creating an arc by opening and closing contacts or making contacts with leads, if you bring conductive tools or equipment inside that space, the risk of arc still exists. It's just minimized by the level of incident energy.
Yeah.
Wes, did you want to weigh in on this one?
No, I think that was pretty good.
Okay. This is kind of interesting. This gets at one of the common themes we have during Arc Flash University event is what's required by law. Is NFPA 70B recommendations for electrical components maintenance required by law, or is it a best practice?
Wes?
70B is in Bravo?
Yeah. Yeah, the maintenance section.
The maintenance section of it.
That's not required by law at this time that I'm aware of. It's best practice, and that's why they call it, a recommendation. But if you want to make sure that your system, your electrical system, and your, whether it be, your customers, if you're servicing for your customers, or it's your own facility, that is the best way to make sure that you are not going to have a problem.
Well, now keep in mind,
Oh, go ahead. I'm sorry.
Oh, I was just going to say, keep in mind that even though NFPA 70E and the National Electric Code are not considered law, the National Electric Code is enforced by the local authority that has jurisdiction. But OSHA has the requirements to provide the training, the equipment, and the safe work practices. They just don't give us the detail. So they refer us out to the industry experts, which happens to be NFPA 70E.
Yeah. OSHA's always considered 70E sort of the de facto guidelines that they're going to use in establishing this. They're saying we're not going to be able to do any better than this, so so we're going to defer to 70E as the standard. I think is a better word than law at this point.
Exactly. What our listeners need to understand is OSHA has to write regulations for every type of environment. They cannot get into the details that an industry specialist like the National Electric Code or the NFPA is capable of doing.
Yeah, and it's actually proven that over time that OSHA has been very responsive and very accepting of 70E and the work that's being done by NFPA to get this standard in place and to continue to improve it. I mean, we all know that 70E is not a couple of tablets brought down from the mountain. It's a continually evolving standard, and there's going to be another version of it coming out in the not too distant future.
Yeah, 2015, and they're already producing or publishing some of those changes. For example, one of the things that they're suggesting their change is the removal of the Category 0 hazard. It's just been too confusing over the years. Yeah. So we're going to see some of those Category 0 hazards will be dropped, and others will be upgraded to a Category 1.
Here's another question from our audience. Equipment with capacitors and other energy storage devices can pose special hazards which may not be evidenced by a contact test. It may require other types of tests. Any comment on that?
Wes, I'm going to throw this one to you.
Okay. Well, when you're dealing with capacitors or any kind of energy storage device, the first thing you're going to have to do is drain the capacitors. So they have what we refer to as short sticks, where you'll actually attach one side of it to a ground source. It's a fiberglass pole, so you're standing at a distance, and you can touch each phase and drain it to ground. Now, after you've done this, you need to apply grounding straps, which will keep it affixed to that system the entire time you work on it. Similar to what you'll see linemen do. If you have a crew of guys that are working outside near power lines, if you were to contact your local energy company and just ask them to de-energize the lines because you'll have heavy equipment near them, what they'll do is they'll actually put these ground straps on there. And it's kind of like an octopus with it brings all the phases together and then to ground. Because you can't apply a lock or tag on things like that, that just ensures visually that you can see that those are de-energized. The same way here. Yeah. Once it's all grounded together, you know the capacitors can't build a charge because they're taken to ground, and then you should be safe to continue your testing.
And one thing I'd want to add to that, Wes, is when you're using that grounding system to take the power out of a capacitor or the storage device, that has to be equipped with some resistance. You don't want to create a dead short to ground. I believe it requires at least a 5 ohm resistance in that lead.
Good. Here's an interesting one, and I think it goes to some of the things, Bobby, that you talked about at the outset of the webcast. Do we have to get multimeters routinely calibrated, and also should the meters be replaced routinely, even if we've never had any issues with the meter itself?
You're going to have to refer to the manufacturer's specifications. I know many of them recommend annual recalibration. Wes, did you want to add to that?
As far as the calibration goes, there's not an actual set-in-stone standard on you must have your meter recalibrated annually. But if you're doing something that requires an ISO 9000 certification, your meter does have to go in regularly and be recalibrated.
So it really depends on the industry and the usage of the meters?
Correct, Bob.
Especially after you dropped it 30 feet.
Yeah, there you go. You mentioned a little earlier about some of the removable faceplates that people are being able to use so that they can do some of the testing from a distance. Have we seen any issues with those coming through the market? I know we've seen a number of them come through our Product of the Year program, and they seem to be another interesting way of trying to get at this measurement issue.
I'm going to give that to you, Wes.
Yeah, I haven't heard anything negative on them. In fact, some of the guys that I've worked with in the past had purchased them, and they're not a lot more expensive. I think they're only like $38 more than the model that I currently use to get the removable display, and I wish it would have been out at the time I purchased it.
Yeah.
It's got a magnet on the back, so you can stick it right on any piece of metal, equipment. Yeah, I have yet to hear anything negative about them.
Yeah. Good.
Bob, I see a question here. I see a question here that I think we should address. It says, I have an ideal Voltcom meter or a Wiggy, and how do I determine the category of the meter? And the answer to that is, if it's not labeled on that meter, then it's not currently up to standards and should not be used in the workplace. Very good.
That's an important one, and I think the whole point of 70E and all this these standards is to bring things up to current specifications, and that's a great point to make. As we're coming to the end of the webcast here, there's one fairly provocative question sitting out there that I wanted to kind of end up on, and that is this one. Now, why won't NFPA or NEC come out and say we're required to have arc flash surveys performed? It's strongly suggested, and it's easier to get buy-in from the corporate officers to make the investment if it's a requirement. Since they don't require it, what are some of the good methods to convince corporate officers that even though this investment will not produce a return, it's well worth the cost?
I'd like to take this one, Wes.
Yeah.
Again, you have to understand that these agencies are writing these standards for everybody. And not everybody can afford or need the cost of a full-fledged arc flash analysis. You've got a mom-and-pop operation that has 15 or 20 employees. This could put them out of business. And the tables that are provided in NFPA 70E may be accurate or adequate for the types of hazards they're exposed to.